The next 30 minutes, we're going to implement an RFC2324 server together. Now that may sound like a fairly dry topic, but RFC2324 is all about coffee. Coffee is a liquid. Liquids are wet, and therefore this talk is certified not dry. But just in case there are any chemists in the audience, as I was preparing this talk, I started thinking, are all liquids actually wet? What makes something wet? Anyway, I consulted multiple experts, and I can tell you now that apparently not all liquids are wet. Both mercury and a eutectic alloy of gallium and indium both feel dry to the touch of human skin. Who knew? And that leads perfectly into a content warning. This talk will contain bad puns, pointless tangents, and pedantry. Was that pedant? Yeah, I've heard it different ways. Depends who you ask. Anyway, you've been warned. So let's talk about Hypertext Coffeepot Control Protocol. That name is a bit of a mouthful. Even the abbreviation is quite long. So for this talk, I'm going to simplify it. And I was taught to always show my working. So CP squared was published on the 1st of April 1998, which is a bit of a strange choice. There's been a lot of products that have been announced on the 1st of April that haven't actually panned out. So for example, I'm still waiting for powdered water, edible computer disks, wipers for BMW badges. Not that I have a BMW, but if I did, I'd want wipers for it. The chippy music player, left-handed laptops. All of these things were announced on the 1st of April and have not been delivered. Very disappointing. But I am pleased to say that CP squared is still around today, so therefore it's an April 1st cursed survivor. And I think that makes it just as important as some of these other survivors. So we've got Apple Computer was found on the 1st of April. I mean, they're doomed, but they're still limping along for now. First Linux kernel came out, big in servers. Next year it's going to be big on the desktop too. And of course, Gmail, which, with apologies to Winston Churchill, is the worst form of email except for all the others. And let's not forget CP squared, the subject of international conference talks. Yeah, very important. All right, enough prattling. Let's get on with the RFC. So CP squared is actually an extension to HTTP. So first we'll just have a go through a bit of background on HTTP to make sure we all understand it. So HTTP is used by both browsers to talk to servers and also native apps and phones, apps, things like that, as a protocol for communication. There are other protocols that also extend it, like WebDAV, and it's a stateless protocol, so it all happens with a request-response cycle. There's lots of different types of requests, and I'll let you look up MDN to see them all. But for the purpose of this quick coverage, we're just going to look at GET and POST, two of the most common methods. So as a general rule, you use GET to fetch web pages or download funny GIFs, and use POST to submit data, like buying a rubber chicken purse or uploading a file. And when you do visit a web page, your browser is probably going to make a whole bunch of requests, not only for the first HTML page, but also for the images, style sheets, scripts, etc. And then those scripts can make additional requests. So most of you probably all know this, but you can see all the requests that are being made using the developer tools of your preferred browser. So for example, in Safari, you can see the Timelines tab to see all the requests that were made for a particular page, including their method, the scheme used, the status code from the web server, and whether or not it was cached. Here you can see it was mostly GET requests along with a single POST request to Google Analytics. If you want to see even more detail about a particular request, head on over the Network tab, choose one of the requests on the left, and then you can see more information. So for example, if you want to see the headers, we can click on the Headers tab, and you can see the headers from the request that got sent, and also the headers from the response that came back. But what are headers? No, not that sort of header. Headers are just metadata about either a request or a response, so data about data. So when we're requesting an image from a web server, the headers might say something like that, which looks kind of complicated, but if you split it onto separate lines, and if you rearrange it to order it by queue value, which is just a fancy way of saying preference, you can probably start to see that first thing we'd prefer is an image in one of those formats. Failing that, we'll take any other image or any other video, and failing that, give us whatever you like. That's the request. On the response, when the server comes back, it'll tell you what it's provided, so you know which one to decode. So if it's an image, you might see a content type of image/PNG. I did warn you there might be tangents. It's time for a tangent. If you are a web developer, sometimes you've got a complex form like this advanced search form, and every time you make a change to your app, you've got to test it again. Rather than filling it in hundreds of times, what you can do is you can fill it in once and then then download the request as a curl command. You can then paste that into your console anytime you make a change, or even put it in various testing scripts. One gotcha I discovered when I was testing this out is that if the response comes back compressed, it's going to be a whole bunch of binary output, and your terminal will not want to display that. There's a few different ways to get around that. You can pipe it to gunzip, or however you say that. You can add a compress flag on the end and curl will do it for you, or you can just remove that except encoding header that we talked about earlier. So here we're getting rid of gzip, deflate, and Brotli compression. All right, end of that tangent. HTTP. Something all HTTP requests have in common is they need a destination. You need to tell them where they're going. So the destination of a request is specified by the URI, the Uniform Resource Identifier, also known as URL often. Technically there's overlap, but they're different. But I'm just going to say URL for the rest of this talk. So in the URL, there's different portions of it. You've got the scheme at the start. We talked about that earlier. And URLs are used for all sorts of different protocols. So there's different schemes available. The colon and the separator, colon's a separator, and the two slashes are a network path designator, followed by obviously the domain name, the network address, could be an IP address also of the server, and finally the absolute path to the resource on the server we're requesting. Okay, once the HTTP server receives the request, it's going to send a response, which can fall into one of 5 different categories or buckets. Variations within each category. So the server will return a status code and a status text to tell you a bit more about it. So for example, if you've got a 200 OK message, starts with 2, it's in the success bucket. 301 moved permanently, starts with 3, it's a redirect. 404 not found is a client error. It's a client error because the client can do something about it. They can change the URL, send the request again, and it might work. So it's the client's fault in that case, not the server's fault. And then last, we have 503, service unavailable. It's another example. So if our web server can't talk to our Ruby app server, the web server might return that. And the client can't do anything about that. You've got to go and reboot it or fix whatever you broke. Okay, so that's HTTP. Now let's have a quick chat about what CP squared is and how it differs from HTTP, other than the obvious changes in hardware. The first difference is that CP squared adds 2 different request methods. Specifically, it adds brew, which is used to tell when the coffee pot should start or stop brewing, and it adds when, which tells it when to stop pouring milk. Great dad joke there. If the coffee pot supports the feature. Another change is for the scheme, it uses coffee instead of HTTP or HTTPS. And that sounds like it's time for another tangent. We all know the web can be a little bit US-centric, but coffee is international. So the people who designed CP squared actually came up with a bunch of different translations you can use. So for example, the word for coffee in Finland is kahvi, excuse my pronunciation. So these 2 URLs are actually equivalent. Since we're in Thailand, we should probably use the Thai word for coffee, which is written up there. Unfortunately, URLs aren't really good at Unicode, unlike Ruby, so you have to actually percent encode it. So the URL would be %e0%. Yeah, I'm not even going to read that. For the purpose of this talk, I'm just going to stick with the Aussie pronunciation and spelling. All right, end of tangent. Moving on. Okay, so what else is different with CP squared? It has some header changes. So the content type should be message coffee pot. The body of the message needs to say coffee message body start or coffee message body stop. And the last change is in the responses. So there are 2 changes to the errors, both in the 400 series. 406 not acceptable gets reused. So if you ask for almond syrup or sugar or something else the coffee pot can't provide, it's supposed to return not acceptable. And if you request coffee from a teapot, you should get the infamous error 418, I'm a teapot. And according to the specification, the resulting entity body may be short and stout. All right, so that's the requirements for CP squared. Now it's time to implement it. But that begs the question, so you've got the specs up there. So how are we actually going to implement it? It's fairly straightforward, but do we build our own web server? Probably not. There's already a bunch of great options out there, and if we build our own web server, then we can't use this with other existing applications. So for example, if Shopify wants to add coffee brewing service for their patrons, they wouldn't be able to do it without changing web servers. Or maybe Stripe wants to integrate CP squared with one of their internal web services to improve caffeination and employee productivity. It's not going to work unless they're not going to change web servers just for this. By the way, if anyone from Shopify or Stripe's in the audience or watching online, I've got pretty brilliant ideas, give me a call. Okay, so clearly it makes more sense to build it into one of the web frameworks. Then the next question is which one? Here are the 4 most popular according to their GitHub stars. But I have to say, once I considered integrating CP squared into each of these, it doesn't look good. Last year, Hanami joined the anti-liquids crew. Rails spat out coffee 5 years ago. And Sinatra's had a recipes repo since 2011. And in all that time, no one has added a recipe for coffee. I mean, how hard is the recipe for coffee? Which means we're relying on Grape. I'm sure the maintainers, are there any Grape maintainers in the audience? No? All right, I'm sure the maintainers of Grape are nice people, but I figured there was no point even trying. I mean, why press Grape when all you're going to get is a little wine? I'll let you think about that one. All right, by the way, I am Hero Conference if you want more jokes. All right, thankfully in Ruby, there is a way to integrate with just about any web server and any web framework. And that way is rack. So rack is a specification that allows any web framework, any compatible framework to run with any compatible server. It's basically a bridge between, any 2 compatible systems, and there's actually quite a long list. The specification also allows us to run additional software in the middle, and that middle software unfortunately doesn't have a cool name like Ultra Connector or Microbridge. The name is middleware. Pretty obvious. I noticed Rado said that naming stuff can be hard. I think if you think naming stuff's hard, you're asking the wrong people. If you want something named, ask an Aussie. And to prove it, I'm going to get some help from the audience. And for that, I need to find an Aussie. There's one surefire way to find the Aussies in any crowd. Aussie, Aussie, Aussie! Oi, oi, oi. Oh, I heard a few of them. If you heard an oi, oi near you, point to the person who said it. There's one over here. Anyone who's not a speaker? All right, come on up, Michael. Oh, is someone at the back? Yeah, all right, come on up, Michael. All right. Unmute that. All right, we're going to play a game called Namin' Stuff. All right, and this is going to prove that Aussies are great at naming stuff. So I'll give you that.
Hello, testing, 1, 2.
All right, so I'm going to show you some slides. You can either look at them here or up there. And you've got to come up with a name. I'll also give you a verbal description.
Where's the cheat sheet?
All right. So, there's this harbour in Sydney. What's it called?
The harbour?
Sydney Harbour. Well done. Okay. There's a bridge that goes over Sydney Harbour. What's that called?
Sydney Harbour Bridge.
Sydney Harbour Bridge. Good name. The bridge got a bit crowded, so we built a tunnel underneath. What do we call the tunnel under Sydney Harbour?
Sydney Harbour Tunnel.
Well done. All right, moving on. I've got a spider with a red back. What should I call that?
A redback spider.
Redback spider, nice. What about a snake that's brown?
Brown snake.
Genius. All right, I think some people are getting a bit uncomfortable with the venomous things, so let's move on to some tourist things. In Coffs Harbour, there's a big banana. What would we call it?
The big banana.
Genius. All right, this one's a bit rare. In Adaminaby, there's a giant trout. What would you call this giant trout?
The giant trout? Big trout.
Big trout.
Big trout.
The big trout. Nice.
Giant is too complicated for Aussies.
Way too complicated. Alrighty. Adaminaby is near some mountains. These mountains are often snowy. What would we call these mountains?
Snowy mountains.
Snowy mountains. Genius name. All right. And when the snow melts, it feeds a river. What will we call that river?
Snowy River.
The Snowy River. All right. Finally, there's a famous poem about a man that comes from this region by Banjo Patterson. What's the poem called?
The Man from Snowy River.
Genius. 10 out of 10. Well done. And as a thank you, I've got these genuine Aussie-made lollies. Feel free to share them at the after party tonight. Alrighty, so that's naming stuff the Aussie way. It's really not hard. Okay, where were we? Yeah, rack middleware. Middleware, great name. It says it right there on the tin. Okay, so rack isn't just one of those specifications that someone made up for a bit of an April Fool's gag or something. It's actually a specification that's used. So let's have a quick look at how it's used in two different web frameworks. First, we've got Rails. So when you start a new Rails app, you can check all the middleware that's included by running the command Rails middleware. And so I did that in Rails 7, and there were 28 middleware objects, rack middleware objects, by default in a brand new app. Rails has a bit of a reputation for being batteries included, so you kind of expect that. Then on the other end of the extreme, you've got Hanami, which has got a reputation for only letting you pick and choose what you want to include. Hanami has a similar command, Hanami middleware, and with a brand new app, even it has some rack middleware included by default. Just the one of them, but still. It proves that this is used throughout Ruby. So it seems like if we're going to build CP squared, we should do it in rack. But how do we actually go about building something in rack? Well, the rack specification is actually fairly straightforward. There's a lot of words there, so let's break it down. First of all, it's a Ruby object, not a class, that responds to call. It takes exactly one argument, the environment, and then it returns a non-frozen array of exactly 3 values: the status, the headers, and the body. So that is actually a working rack app right there. So what does that look like in practice? Well, here's a diagram showing what it might look like if we didn't have any middleware, we're just using rack. So we've got the web browser, we've got a web server running Puma, we've got a Ruby app running Sinatra. And so when the client sends a GET request, Puma takes that, puts it in the environment, and does app.call-env to the Sinatra app. Sinatra does whatever it's going to do, processes the response, and then returns that 3-part array to status code, headers, and body. And then Puma turns that into HTML, sends it back to the client. Pretty straightforward. But what's clever about this design is that it actually allows you to chain applications together. So one after the other. So you can have 0 middleware like we've got here. You can have 1 like Hanami starts off with. You can have 28 like Rails starts with. Or if you want, you can try and add 1,000 of your own. So let's do that ourselves. So first, we're going to take that same middleware, but we're going to modify it slightly. So the first thing we do is we use the initializer to tell it what the next link in the chain is. So whatever gets past the initializer, that'll be the next link. And then whatever we receive from the environment, we can just pass that on to the next link. Pretty straightforward, we just .call it. So let's modify that diagram. We've now got rack in the middle. So Puma still does app.call, but this time it goes to rack. Our do nothing middleware just sends that straight on to Puma. Puma does its thing, returns its array, and we just pass that straight back to Puma. So that's obviously kind of pointless, but it shows you the power of rack middleware. You've actually got 2 chances to make changes. So you can make changes on the way to that way. I've got to go right to left for you guys. You've got chances to make changes on the way to the app server, and you've got chances to make changes on the way back to the client or the previous link in the chain. In my first tangent, I said you could modify your call command to remove the accept encoding header. We could actually build a rack middleware that does exactly that. And what would that look like? Well, we take that same app, and all we do is we modify the environment before sending it on to Sinatra, or whatever's the next link in the chain. And as Matt said, Ruby is awesome. It's really simple. Just env.accept and remove that key. Another simple example might be if we want to add some timing info. So we want to time how long our Ruby web app takes. We can do that pretty simply. First, we use multiple assignment, status, headers, body, to take those 3 array items, put them into variables. And doing that allows us to wrap that request in a before and after, and then we can calculate the duration and just merge it straight into those headers. So again, reads really nicely. You've got to love Ruby. Okay, and that sort of highlights being able to change stuff either direction, highlights the possibilities, and basically they're endless. So, for example, we could add or remove cookies, we could serve requests from cache without bothering our Ruby server, or, and I'm guessing this is the reason most of you are here today, we could build HTTP CP ourselves. All right, let's figure out how to do that. So we've got our spec we came up with earlier. Let's build it in rack. Because we're doing it in rack, we need to add one more implicit requirement. We're going to use rack middleware to do this. All right, so first of all, let's add some rack middleware to an existing app and confirm it's working. I'm using Rails for this example, but it's fairly similar in other frameworks. So the first thing I did is I put some puts debugging so that I know that it's being loaded and it's being called. And then I stuck it in the lib/middleware folder, convention over configuration. Once I've done that, I modified config/application.rb to require that file and to insert the middleware at the head of the queue. So I used middleware.insert before 0, puts it right at the top so nothing else messes with the request before I get to deal with it. And do not forget to relaunch the app. Anytime you make a config change or update your rack middleware, ask me how I figured that out. All right, so on about my 18th attempt, I finally got it working, and I booted up and I saw the message I was looking for in the, is everything working? Oh, we're back. No, I'm back. Yeah, we're back, good. The message came up in the logs and a second time for Tailwind, but that's neither here nor there. And when I passed a request along, it showed up in the logs. All right, so our rack middleware is working. It's working there. So next thing, how do we check for a copy scheme? So first of all, there's because we're using rack and we're passing other things onto our web app, instead of returning a bad request if it's not coffee, we'll probably just ignore the request and let Ruby deal with it, let our other app deal with it. So the way do we do that? We need all the different coffee translations. So I throw them in a constant, and then we check in the environment under rack.url scheme to see if the scheme matches. If it does, we then go into our block where we unescape it back to Unicode so we can actually read it, we log it, and we return a placeholder HTTP response to say, got your coffee request. If it doesn't contain the coffee scheme, then we just pass the request on to the next link in the chain, as we saw earlier. So with that done, and once we reboot our server, I made some test coffee requests and they all worked in different languages. And then just to make sure I hadn't broken my actual app, I also sent a regular request and Rails dealt with it as you would expect. And in the logs, we can see the 3 that we processed ourselves and the 1 that got passed on to Rails. All right, looking good. Only 4 more requirements to go. In the interest of time, we're not going to go through all 4. I'm just going to show you one because they're all actually pretty similar. So the first thing we want to do is check for a brew or post method. Otherwise, we're going to return a 405 method not allowed. So we do that by adding a guard clause. That's up there in green. The guard clause just returns early if there's a problem with our request. And the way it does that, it returns a method not allowed error unless there's a valid HTTP method. Reads just like English. Really nice. Okay, how do we actually do that? Well, we check the method is valid by looking in the environment again, as we've seen before. Is request method set? If it is it brew or post? If it's not set or if it's not brew or post, then we return false. And then when we return false, that triggers the guard clause and it returns the HTTP error. How do we return a HTTP error? It's just like any other HTTP response, just need that array of 3 items. So 405, we add our headers. In this case, we're adding a header to say what is actually allowed so the client knows what it should have sent. And we put a human readable string in the body just in case anyone's reading that. Okay, so that's the first requirement. The next 3 are basically the same. 3 more guard clauses, 3 more different error types. At this point, I really would have loved to show you a working coffee pot control server. But when I pitched this talk, I vastly overestimated my electronics abilities and also my time. But I am hoping to complete it one day, so maybe one day there'll be a sequel to this talk. But for now, I'm just going to wrap up by covering what we talked about. So we looked at HTTP with its request-response cycle, some common methods, how URLs work, what the headers do, and also the different response buckets or categories. We then looked at CP² and how it extends HTTP. So that may not be super relevant to us in terms of implementing this, but if you're working with WebDAV or if you're doing anything else that extends HTTP, this might actually come in handy. We also looked at rack and how that works and how it integrates different web servers with different frameworks. And we also learned how you can have rack middleware that lets you chain different requests together. And then finally, we implemented our own rack middleware from scratch to implement the error checking portion of CP². And we learned how to integrate it into an existing Ruby web app. So that's all I've got for you today. Thank you for your time. Thank you for the organisers for organising this, and for all of you for being part of the Ruby community. I hope you enjoyed yourself, and I hope you enjoyed the rest of your conference.